We shall commence this module by studying about deadweight laws. At the very center of public finance analysis lies the distortions introduced by taxation. Tax induces reductions in economic efficiency are known as deadweight losses or the excess burdens of taxation. The latter signifying the added cost to the taxpayers and society of raising revenue through taxes that distort economic decisions. It explains how a society loses in terms of its total surplus when it is taxed. In general context, excess burden can be caused in market conditions other than perfect competition like monopoly. Whenever a commodity is taxed, it distorts the market in such a way that consumers are discouraged to consume and producers are discouraged to produce, and the equilibrium quantity in the market falls, hence reducing the total surplus in the market. The tax leads to an excess burden in the market due to decreased quantity traded. Excess burden is well defined only in the context of a specific comparison or conceptual experiment. If one simply seeks the excess burden of a particular tax policy, there are many equally plausible answers. So, in order to obtain a unique meaning, it is necessary to be more specific. For example, the excess burden of a 10% tax on retail sales varies not only with the initial conditions of the tax system, but also with the direction of change, that is, whether the tax is being added or removed. Taxes almost invariably have excess burdens because tax obligations are functions of individual behavior. The alternative pure lump sum taxes are attractive from an efficiency perspective, but are of limited usefulness precisely because they do not vary with indicators of ability to pay, such as income or consumption, that are functions of taxpayer decisions. Thus, even though tax analysis often starts with the simple case of a representative household, it is household heterogeneity and the inability fully to observe individual differences that justify the restrictions commonly imposed on the set of tax instruments. Designing an optimal tax system means keeping tax distortions to a minimum, subject to restrictions introduced by the need to raise revenue and maintain an equitable tax burden. In the theory of microeconomics, we study the interactions between different economic agents like consumers, producers and social planners, etc., to come to a general equilibrium in the society. This determines the allocation of resources in such a manner that the scarce resources having alternative uses can best satisfy the wants of the society. The allocation in the theory subjects itself to answer three central questions, that is, what to produce, how to produce and how much to produce. Economists and policy makers often want to know not only whether particular policies make people better off or worse off, they also need to quantify how much better off or worse off different consumers are. The tools are developed that allows us to measure consumer welfare in objective terms without us having to measure happiness directly. This way of thinking about welfare effects from institutional or policy changes allows us then to address the following question. Is it at least in principle possible to compensate those who lose from the policy with part of the gains accruing to those who gain from the policy? If the answer is yes, then at least in principle there is a way to make the world more efficient, to make some people better off without making anyone worse off. If the answer is no, on the other hand, then we know that the new situation will be less efficient. Put differently, if the winners from a policy gain more than the losers lose, the policy could in principle be accompanied by a compensation scheme that would result in unanimous approval of the policy. This part in the microeconomic theory connects to the optimal allocation of resources. An allocation is said to be optimal or best if it satisfies the condition of being Pareto. Real world policies come at best with imperfect compensation schemes and thus rarely enjoy unanimous approval. We should not accept a policy right away without comparing the benefits than cost associated with it, because in some instances we may in fact place more weight on the decline in welfare of those who lose than on the gains in the welfare of those who win. Pareto optimality conditions state that a given allocation is Pareto optimal if there is no other allocation where anyone can be made better off without making someone else worse off. The Pareto optimal allocation in general equilibrium in a two good, two consumer case is represented by Edgeworth box diagram. The efficiency of an allocation can thus be measured using Pareto optimality criteria. The implementation of a certain policy thus depends on weighting who loses and who gains. After studying this module, you shall be able to know how to measure consumer welfare in monetary terms, learn about the marginal willingness to pay and consumer surplus, understand the concept of deadweight loss and inefficiency of taxation, measure deadweight loss through changes in consumer and producer surplus. Now we will understand the inefficiency of the taxes. First, we will study about measuring the consumer welfare in monetary terms. We will begin our analysis of the measurement of the consumer welfare by quantifying how much better off or worse off consumers are for being able to purchase goods voluntarily at given market prices. Put differently, we will ask how much better off a consumer when he participates in market rather than being excluded from it. This will lead us to define the terms like marginal and total willingness to pay as well as consumer surplus. We will then proceed to demonstrate how policymakers might analyze the impact of particular proposals on consumers when those proposals change the relative price in an economy. In the process, we will also learn the importance of recognizing the difference between income and substitution effects and how the substitution effect contributes to the deadweight losses for the society while the income effect does not. Now we will discuss the consumer surplus first. Marginal willingness to pay. Let's ask how much a consumer would be willing to pay for that gallon given that he ended up an optimal bundle, say A. For the first gallon, he can measure this willingness to pay by finding the slope of his indifference curve, the marginal rate of substitution at 1 gallon. Suppose that this slope is minus 20. This tells us that the consumer was willing to trade $20 worth of other consumption for the first gallon of gasoline. We can then proceed to the second gallon and find the marginal rate of substitution at 2 gallons. Suppose that it is minus 19. This tells me that he would have been willing to give up $19 of other consumption to get the second gallon of gasoline and so on. The following diagram shows the marginal rate of substitution and the budget constraint of the person through which he is being able to derive MWTPA. For each gallon of gasoline with the marginal rate of substitution at bundle A being equal to the price of gasoline. At the end of this exercise, we will get the consumer's marginal willingness to pay, that is MWTP, for each of the gallons of gasoline he consumed and all the additional gallons that he chose not to consume. In the lower panel of the diagram, we can simply plot gallons of gasoline on the horizontal axis and dollars on the vertical axis. The marginal willingness to pay curve for a consumer who ends up on the indifference curve containing bundle A is then simply plotted by plotting the dollar values of MRS at each gallon of gasoline. Moving on to the marginal willingness to pay curves and substitution effects. There is, however, a slightly different way of deriving marginal willingness to pay curves that builds more directly on material we have covered in the above. The top panel of the diagram begins with the same initial budget and optimal bundle A as we started within diagram A. Instead of directly identifying the marginal rates of the substitution on the indifference curves that contain bundle A, however, we now imagine a price increase from P to P dash and then illustrate the compensated budget and get the substitution effect. We then illustrate the bundle B and bundle C either to the right or left of B depending on whether the good on the horizontal axis is a normal or inferior good. Here we are assuming that gasoline is a normal good and thus place bundle C to the left of B. Consider the diagram. Specifically in the lower panel of diagram, we illustrate the quantity consumed at bundle A at the original price P and the quantity consumed at bundle P at the new price P dash. But notice that all we are doing is plotting the slope of the indifference curve that contains bundle A at two different quantities. We could imagine doing this for many different price changes, each time finding the corresponding compensated budget and the new optimal bundle on that compensated budget. In doing so, we would end up plotting the marginal rates of substitution at the different quantities, leaving us with the same marginal willingness to pay curve as in the lower panel of diagram. For this reason, The marginal willingness to pay curve is often referred to as the compensated demand curve, while the regular demand curve is sometimes referred to as the uncompensated demand curve. Only time the own price demand curve and the marginal willingness to pay curves are the same is when there are no income effects with respect to the good whose demand curve we are drawing, and that is true only for the tastes that are quasi-linear in that good. We will now understand the total willingness to pay and consumer surplus. We begin by asking how much the consumer might be willing to pay for the opportunity to be able to purchase gasoline at the market price rather than not being able to get access to the gasoline market. The answer can now be read off the marginal willingness to pay curve. We have just derived once. We have identified two further concepts in the marginal willingness to pay graph. First, we need to identify my total willingness to pay for all the gasoline the consumer is purchasing in the market. The second, we need to subtract from this the amount that the consumer actually had to pay in the market. Now, the difference between these two amounts is how much better off he is for being able to participate in this market, how much more he would have been willing to pay than he actually had to pay. Diagram below replicates the marginal willingness to pay curve we just derived, illustrating the consumer's marginal willingness to pay for each of the gallons of gasoline that he is consuming, given that he ends up consuming at bundle A when he faces the market price P. His total willingness to pay is equal to his marginal willingness to pay for the first gallon plus his marginal willingness to pay for the second gallon, etc., which is roughly equal to the area below the marginal willingness to pay curve. His total willingness to pay is therefore the area under the marginal willingness to pay curve up to the quantity that he consumes. The amount he actually had to pay is simply equal to the price per gallon of gasoline times the number of gallons he chooses to consume, which is equal to the shaded area formed by the vertical distance equal to the price and the horizontal distance equal to the number of gallons of gasoline consumed in diagram. Finally, consumer surplus, that is the difference between what he was willing to pay for the gasoline consumption and what he actually paid, is the difference between the two areas we have identified. This is how much better off he is for being able to participate in the gasoline market, and therefore the most he would be willing to pay to get access to a market where gasoline sells at P per gallon. Further, we now discuss about the distortions of the taxes. Governments use taxes to raise revenues that in turn fund expenditures on a variety of government programs. These programs may have enormous benefits, but to the extent that they are funded through taxes, they come at an economic cost which economists refers to as the deadweight loss from taxation. Often students think that pointing out this makes all economists raving anarchists that being an economist means being against all taxes and all government expenditures that are funded through taxes. But recognizing an economic cost of taxation does not mean that one has to oppose to all taxes. Like recognizing a cost to going to the movies implies that one is against going to the movies. After all, the benefits from certain government programs may well outweigh these costs, just as the enjoyment of the movie might outweigh the cost of watching it. It does, however, lead us to think more carefully about the relative cost of different kinds of taxes, and we can now use the tools we have developed to illustrate how such cost can be measured. To see what makes a particular tax costly and to see how we can measure this cost objectively, we will try to answer the following question. How much would a taxed individual be willing to bribe the government to get the tax reduced? We will then compensate this amount to the amount that the individual is actually paying in tax. If the maximum size of the bribe the individual is willing to pay is larger than her actual tax payment, then we know that there exists, at least in principle, a way to raise more revenue from the individual without making her worse off. The difference between the hypothetical bribe and the tax payment is a measure of how much more the government could have raised without making anyone worse off, and it is our measure of deadweight loss. One way to think of deadweight loss from taxation is to imagine the government collecting taxes in a bucket that has a hole in it, and as the government passes the bucket leaks. What remains in the bucket is what the government gets to use to provide public programs and services, and what leaks from the bucket is the deadweight loss that no one gets but that we could get to if we just found a better bucket. The challenge is to find a bucket, a tax that has a small hole so that the leakage is minimized. But why is there a hole in the first place? Now we will learn about some intuitions on the deadweight loss and inefficiency of taxation. The question is not theoretical and the answer is not immediately obvious. In fact, often students are puzzled at this point. Why would anyone ever be willing to pay more in a bribe to get rid of a tax that she is paying in taxes when the tax is in place? Why do we think that we can find another tax that will raise more revenue while not making people worse off? Consider the following extreme example. I like to drink soda and I especially like to drink the imported soda variety. Suppose the domestic soda company X convinces the government to impose a large tax on imported soda, and suppose that this leads to a sufficient increase in the domestic price of the imported soda to cause me to switch to the domestic. Notice that because I have substituted away from imported and towards domestic soda, I end up paying no tax at all. At the same time, I have clearly been made worse off by the imposition of a tax on imported soda and would therefore be willing to pay something to get the government to abolish this tax, despite the fact that I do not pay any of the tax when it is imposed. With the government not raising any revenue and me being made worse off, we have identified a bucket that has not bottom, no tax revenue from me is actually reaching the government even through the imposition of the tax is making me worse off. Stated otherwise, society has been made worse off without anyone getting a benefit, and that is called deadweight loss. It is also what makes taxes inefficient. In theory, we define a situation to be inefficient if there is a way to change the situation and thus make someone better off without making anyone worse off. The tax on imported soda is inefficient because the government could have raised more money from me without making me any worse off by thinking of a different way of raising money, finding a different bucket and does not leak so much. For instance, they could have just come by my house and taken some money, leaving the price of the imported soda unchanged and thus not giving me an incentive to switch to the domestic extreme gives us an initial insight into what it is about taxes that makes taxes costly. By altering the relative prices in an economy, taxes cause consumers, workers and savers to substitute away from taxed goods and services and toward untaxed goods and services. To the extent that this substitution actively happens solely because of the change in the opportunity cost, that is to the extent to which taxes give rise to the substitution effect, taxes are distortionary and inefficient ways of raising revenues. Many real world examples may be less extreme. They may lead us to consume less of the taxed good and more of the other goods without causing us to eliminate our consumption of particular taxed goods. But the basic intuition remains the same. That is, to the extent to which taxes change opportunity cost and thus cause us to alter our consumption plans solely because of those changed opportunity cost, we are worse off without contributing to the government's effort to raise revenues, and society has incurred a deadweight loss. We can now use the tools we have developed to show more formally that this entire deadweight loss happens because of the substitution effect, which are therefore the underlying cause of the leak in the bucket. Moving further, let us now study about measuring deadweight loss. The theory of consumer surplus is very tidy in the case of quasi-linear utility. Even if utility is not quasi-linear, consumer surplus may still be a reasonable measure of consumers' welfare in many applications. Usually the errors in measuring demand curves outweigh the approximation errors from using consumer surplus. In figure, we have illustrated the change in consumer surplus associated with a change in price. The change in consumer surplus is the difference between two roughly triangular regions and will therefore have a roughly trapezoidal shape. The trapezoid is further composed of the two sub-regions, the rectangle indicated by R and roughly triangular region indicated by T. Changes in consumer surplus. The change in consumer surplus will be the difference between two roughly triangular areas and thus will have a roughly trapezoidal shape. The rectangle measures the loss in surplus due to the fact that the consumer is now paying more for all the units he continues to consume. After the price increases, the consumer continues to consume X units of the good and each unit of the good is now more expensive by P double dash minus P dash. This means he has to spend P double dash minus P dash into X double dash more money than he did before just to consume X double dash units of the good. But this is not the entire welfare loss. Due to the increase in the price of the X good, the consumer has decided to consume less of it than he was before. The triangle T measures the value of the lost consumption of the X good. The total loss to the consumer is the sum of these two effects. R measures the loss from having to pay more for the units he continues to consume, and T measures the loss from the reduced consumption. Let us now study about producer surplus. The demand curve measures the amount that will be demanded at each price. The supply curve measures the amount that will be supplied at each price. Just as the area under the demand curve measures the surplus enjoyed by the demanders of a good, the area above the supply curve measures the supply enjoyed by the suppliers of a good. We have referred to the area under the demand curve as consumer surplus. By analogy, the area above the supply curve is known as producer surplus. The term consumer surplus and producer surplus are somewhat misleading, since who is doing the consuming and who is doing the producing really doesn't matter. It would be better to use the terms demander surplus and supplier surplus, but we'll bow to tradition and use the standard terminology. Suppose that we have a supply curve for a good. This simply measures the amount of a good that will be supplied at each possible price. The good could be supplied by an individual who owns the good in question, or it could be supplied by a firm that produces the good. We will take the latter interpretation so as to stick with the traditional terminology and depict the producer surplus curve in diagram. If the producer is able to sell X star units of her product in a market at a price P star, what is the surplus she enjoys? It is most convenient to conduct the analysis in terms of the producer's inverse supply curve PSX. This function measures what the price would have to be to get the producer to supply X units of the good. We will now discuss about calculating the gains and losses. If we have estimates of the market demand and supply curves for a good, it is not difficult in principle to calculate the loss in consumer surplus due to the changes in government policies. For example, suppose the government decides to change its tax treatment of some good. This will result in a change in the price that consumers face and therefore a change in the amount of the good that they will choose to consume. We can calculate the consumer surplus associated with different tax proposals and see which tax reforms generate the smallest loss. This is often useful information for judging various methods of taxation, but it suffers from two defects. First, as we have indicated earlier, the consumer surplus calculation is only valid for special forms of preferences, namely preferences representable by a quasi-linear utility function. We argued earlier that this kind of utility function may be a reasonable approximation for goods for which changes in income lead to small changes in demand, but for goods whose consumption is closely related to income, the use of the consumer surplus may be inappropriate. Second, the calculation of this loss effectively lumps together all consumers and producers and generates an estimate of the cost of a social policy only for some mythical representative consumer. In many cases, it is desirable to know not only the average cost across the population, but who bears the cost. The political success or failure of policies often depend more on the distribution of gains and losses than on the average gain or loss. Let us now summarize what we have learnt in this module. While the theory of deadweight loss measurement has a long and colorful history that dates back to the 19th century contributions of Jules Dupuit 1844 and Fleming Jenket 1871 and 72, economists seldom measured actual deadweight loss prior to the pioneering work of Arnold Harburger in 1950 and 60s. In two influential papers published in 1964, Harburger 1964 derived the approximation used to measure deadweight loss, and 1964b applied the method to estimate deadweight losses due to the income taxes in the United States. Harburger shortly thereafter in 1966 produced estimates of the welfare cost of US capital taxes. A generation of empirical studies by other scholars followed the publication of Harburger's subsequent survey article in 1971. A major practical difficulty in measuring the excess burden of a single tax or of a system of taxes is that excess burden is a function of demand interactions that are potentially very difficult to measure. For example, a tax on labor income is expected to affect hours worked, but may also affect the accumulation of human capital, the intensity with which people work, the timing of retirement, and the extent to which compensation takes tax favored in place of tax disfavored form. In order to estimate the excess burden of a labor income tax, it is in principle necessary to estimate the effect of the tax on these and other decision margins. Analogous complications are associated with estimating the excess burden of most other taxes. In practice, it can be very difficult to obtain reliable estimates of the impact of the taxation on just one of these variables. The analysis of excess burden and optimal taxation is one of the oldest subjects in applied economics, yet research continues to offer important new insights that build on original work of Dupuit, Jenkin, Marshall, Pigou, Ramsay, Hoteling, and others. Fundamentally, it remains true that departures from marginal cost pricing are associated with excess burden, that the magnitude of excess burden is roughly proportional to the square of any such departure, and that efficient tax systems are ones that minimize excess burden subject to achieving other objectives. The contribution of the modern analysis is to identify new and important reasons for prices and marginal costs to differ, to assess their practical magnitudes and to consider their implication for taxation. One of the major developments of the last 50 years is the widespread application of rigorous empirical methods to analyze the efficiency of the tax system. Empirical work not only assists the formation and analysis of economic policy, but also plays a critical role in distinguishing important from less important theoretical considerations, thereby contributing to further theoretical development. Properly executed empirical analysis is not only consistent with the welfare theory that underlies normative public finance, but also takes the theory further by testing its implications and offering reliable measurement of parameters that are critical to the assessment of tax systems.